Good morning. My name is Sibel Schaffner, and I am the program manager for the Advanced Sensors and Instrumentation program. I will provide a brief overview on the program and also talk about the topics that fall under my area in this solicitation. So first slide, the vision of the Advanced Sensor Instrumentation program is to develop new sensors and instrumentation to address technology gaps for monitoring and controlling reactors in fuel cycle facilities. Our goals are to provide any R&D programs with INC capabilities to support the reactor or fuel cycle development, such as in-pile instrumentation for fuels and materials testing necessary to qualify them for commercial deployment. Second, we want to provide new innovative measurement and control capabilities such as sensors for harsh environments, advanced control capabilities, and fault-tolerant operations. And third, we want to help R&D needs for successful deployment of these new technologies, such as digital technology qualification, advanced operational concepts, and focused demonstration of the advanced technologies to provide a science-level evidence for regulatory acceptance. So here you can see the cover for our annual summary, which contains one-page summary of all the current ASI projects, and the latest is available on our website listed down there. Okay, so this slide shows you how our research is organized to support the Department of Energy's Office of Nuclear Energy mission to advance the U.S. nuclear power in order to meet the nation's energy needs by enhancing the long-term viability and competitiveness of the existing U.S. reactor fleet, developing an advanced reactor pipeline, and implementing and maintaining the national strategic fuel cycle and supply chain infrastructure. So we have organized our research into 4 areas: advanced sensors, where we're working to develop a fundamental understanding of the sensor's performance and to improve physical measurements, accuracy, and reduce uncertainty. The second area is digital monitoring controls. We're looking to provide increases in control system performance and self-calibration capabilities. Third area is nuclear plant communication. We're looking to advance communication technologies that support greater data generation and transmission demands while maintaining reliability, resilience, and data security. And the last area is advanced concepts of operation to develop and test higher integral control system architectures where new human and system interaction is defined. Since we're a cross-cutting program, our goal is to find research that supports and is applicable to multiple reactors or fuel cycle application. For this year's solicitation, we will be requesting proposals in the areas identified during our digital environment workshop that was held in Argonne in June 2018. For more information on this workshop, we have the information, the presentations, and a summary posted on the GAIN website, which is gain.inl.gov. And the workshops, you can find it there. And we have this year 3 subtopics under NEET-2, 1 topic under NEET-3, and 1 topic under NSUF-1.1, which I will cover next. I just want to make note that our topics are open to universities and laboratories as leads. Industry can participate as a collaborator, and if industry is interested in leading a project under this area, they should go visit the new industry FOA, which has a cross-cutting area of R&D portion where we can address this type of projects. So, okay, so the first topic is looking for state-of-the-art INC technologies for control rooms and plant control and protection systems for advanced reactors. The goal here is to reduce license requirements for testing, validations, and verifications for new reactors that have design safety features such as passive systems. We need more research on rad-hard electronics for digital components that can be used in new advanced reactors. For example, placing microprocessors and programmable logic controllers for distributed control systems in high radiation areas that support reactor control and monitoring systems. We want to automate and enhance plant operations such that plants can be monitored from outside or consolidate functions into a one control room station so to reduce the operation costs. Overall, we're looking for technologies that can streamline and simplify the design process for safety and non-safety related systems to afford improvements in maintenance, operation, and long-term costs of managing the plant. It should also result in improved reliability and operation in the control room, including staffing efficiencies. Okay, the second topic is looking for advanced online monitoring for nuclear plant operation and maintenance to be integrated into the advanced nuclear reactor designs that can improve system performance, reliability, economics, and security. So we're looking for applications that provide a cost-benefit analysis. We want research and demonstration of the integrated predictive analytics and risk-informed condition monitoring system that will take nuclear into the future and specifically will enable a transformational approach to supply chain and asset management. Examples of these include new types of digital technologies that are beyond what can be accomplished today by either conventional analog technologies or existing digital systems. For example, more resilient systems that anticipate the behavior of plant system and react accordingly to manage system performance can avoid disturbance. The results for systems that are designed to operate only at steady state output. Physics and model-based control program systems may be appropriate for some systems that can be modeled and managed more efficiently by advanced model-based control technologies. Okay, under the third topic, we're looking for new sensors and instrumentation technologies for advanced nuclear plants that can survive the harsh environment. We want versatile and resilient instruments that can provide multiple and complementary measurements. We're also interested in materials development or application specifically for nuclear sensors application. In this area, we're also interested in new radiation-resistant measurement sensors that can support in-pile or in-core measurements, such as local radiation and temperature, dimensional changes, materials properties, fission gas releases, for example. So what I mean here, not currently under development, I'm talking about lower TRL levels, technology readiness levels. So we're looking for new ideas in this area. So on the topic NEET-3, we're looking for conceptual design applications to digitally and electronically support nuclear facilities field activities. We're looking for integrated and seamless applications for real-time measurements. For example, are digital cameras integrated into goggles or safety glasses, radiation sensors integrated into the shoes, boots, or gloves, location sensors added to IDs or dosimeters, engineering information that is visually available through goggles or something similar to a Google glasses. Since this is more like a feasibility phase for proof of concept, we are requesting applicants to provide a plan for the next phase of technology for the testing and demonstration of this technology, or the proposed technology. Now moving to switching the areas in the solicitation under the Nuclear Science Research Facility 1 work scopes. all the applications will be for project coupling with R&D with NSUF access. So under my area is NSUF 1.1 topic, and we're looking for proposal for advanced materials for sensors. Under this area, we want to give the opportunity to test any materials that are proposed for advanced sensor for survivability and performance in nuclear environment. Please provide a description of the materials, what irradiation, post-irradiation examinations are needed, and how these materials will benefit new sensors and applications. In the second area, we have advanced sensors. There's opportunity to test the advanced sensors and associated instrumentation for nuclear energy applications. Again, same, please provide a description of the sensor, what irradiation and post-irradiation are needed, and the purpose and application of your sensor. Please know that this is an opportunity to test your developed materials or sensor in an irradiated environment and document with results. It does not support development R&D, so no new R&D here. New R&D development should be proposed under the NEET-2 topics. Okay, then we're getting to the end. In conclusion, some expectations we have for this FOA is, as you plan your proposal, I want to stress that we're looking for advanced INC technologies that support the reactor and fuel cycle development and deployment. We're looking for improved economics and safety. We want to have your technology demonstrated in a setting that represents the nuclear power industry, nuclear environment. And we're looking for innovative and revolutionary cross-cutting technologies that can be applied to multiple reactor designs and fuel cycle concepts. And here's our contact information. Craig Primer and Brendan Hendricks from the Idaho National Laboratory are the technical lead for these areas and are available to help answer any questions. So with that, are there any questions?
So let's begin in NEET 2.1. Regarding the statement, rad-hardened electronics for digital-based components, can you comment on the expected radiation levels or perhaps the location of interest for rad-hardened electronics? Do locations include in-vessel electronics?
Yes, and now we'll, for the specific proposal, I guess it will depend on the application of your electronics. So I will let Craig add more comments to that if he has the specific numbers, because it depends on the type of reactor design.
Yeah, we're talking about megarad area internal or in the reactor for inline, for in-core measurements, as well as electronics outside of the vessel that would support PLC or microprocessing.
Yeah, the focus of this topic this time is on advanced reactors. So if we talk which advanced reactor you want to be, you can match up their specific needs for that type of reactor.
Does radiation-resistant instrumentation also require resistance to corrosive, for example, molten salt, lead, or other environments?
If it's going to be for a molten salt application, yes, unless they can somehow protect it.
Under NEET 2.3, can funds be used for irradiation testing and material test reactors?
Can funds be used for
irradiation testing in materials test reactors? I'm assuming they're referring to a university test reactor.
I would have to understand more for what purpose, because we're focusing on advanced reactor, but if it's a new technology that can be applicable for, I think they're saying for test reactors, right? Specifically, if you can be something that can be expanded also to advanced reactors, maybe.
Thermophysical and other properties can be accurately and quickly calculated using remotely placed sensors of temperature, heat flux, stress, deformation, etc. Are you interested in proposals for developing fast computing algorithms for these remote measurements to predict such properties inside the reactor?
I would say, would it, Craig, can you answer that one?
I think we would be. I would be interested in that application that could be added in and integrated into some of the sensors that we have in the current proposals.
That's a good thing.
For the NEET 2.2 scope, are you interested in sensors for advanced reactors such as MSRs?
For the online monitoring and diagnostic technologies, 2.2? Yes.
For NEET 2.3, should we address all bullet points that were presented or just one of those topic areas?
Let me go back. Under NEET-3 or 2.3? Sorry.
This is for 2.3.
Okay, one more. I think it can be some of this. I don't think it has to be all of them in one, but more like examples of what we're looking for. And I don't know if Brenda's on the line. He may be able to provide a little bit more information.
We don't have Brendan on the line right now. At least I couldn't get his microphone working. So if you do need further clarification than that, please do reach out to Sue Bell and Brendan. Their contact information is on the NEUP.gov webpage.
And
under
it's on the end of the
tab.
slide.
Oh, and it is on the slides. That's correct. It's under the R&D tab under technical points of contact. So next question. In regards to rad-hardened electronics, are you looking for radiation resistant / identification algorithms?
Radiation resistant, yes. What do they mean by Craig, can you address the last part?
So I would need a little clarification on that question. I'm not quite sure the application for that algorithm. If it's embedded in a PLC, it would have to be able to perform as expected. So I just need a little more information.
Yeah, that question can be answered offline. Then if the participant here can give a little bit more information in an email, then Craig or Sue Bell can answer that. Okay, those are all the questions we have. Thank you, Sue Bell. Thanks, Craig, for being here and being on online.